Alrighty, so I made these 8 problems today. I said if I can get around to it, I'll make this video. It is now just after 7 o'clock. I'm going to record a math video because that's just how much I care. Alrighty, so let's start with the first one here. This is only the second video I'm making on this wonderful Surface Pro tablet, low-key flex. So we'll see how it goes. Alright, so the first one here, we have a quadrilateral with sides 10, 7, and 11 that's circumscribed about a circle. So this is one of those walk-around problems where we find the fourth side. So I'm going to draw myself a circle, and then I'll go ahead and circumscribe, and I don't know why that didn't snap into a perfect circle. There we go. All right. So I'm going to circumscribe about. And then I'm going to have to undo that. See, it snaps when I didn't want it to, but that happens. Okay. Alrighty. Wonderful. Yeah, it's their circle, center. So I've got 10, 7, and 11. That's a 7. There we go. And I want to find that fourth side. Now, to do these problems, I'm going to go ahead and start anywhere I want. And by our two tangent theorem, if I call this guy x, this would have to be x as well, right? So we have this guy and this guy. Those are both x's. So if I know that that length is x, if I want the other part, I'm going to switch colors here. That length, I would do 10 minus the blue length of x, which would give me then this length as well, right? Okay, so this is also 10 minus x by my two tangent theorem. If I have an exterior point drawn to the point of tangency, then those two segments right there are going to be congruent. So the same concept now, but with the 10 minus x, I can go ahead, and I guess I'll use green here. This particular segment is going to be, try to draw that a little better. Okay, this is going to be 7 minus 10 minus x. Okay, so I'm going to do a little algebra here. I'm going to distribute my negative in, and I'll have 7 minus 10 plus x, and I'm going to get negative 3 plus x. So I'm going to jot that down for this segment, negative 3 plus x. Alrighty, I'm going to pop back to blue. This segment is going to be 11 minus the other piece, which is the negative 3 plus x. Cool. And then I can distribute this negative again and get 11 plus 3 minus x. And if I simplify that, it's 14 minus x. Now that 14 minus x is also right here. And if I know two pieces, right, if I know this length is x and this length is 14 minus x, if I add them together, it ends up being 14. Woo! Exciting stuff. My x's cancel out on me. Boom, boom. Bippity boppity, we're ready to rock. All right, so that's problem number 1 there. Good stuff. Now let's see if I can figure out how to select all this. Cool. And I'm going to shrink that down. Can I shrink it down? I don't know. Perhaps I can at least just move it out of the way. Okay. Wonderful. I really don't know what I'm doing with this thing yet. All right. Number 2. So for number 2 here, I want to find all the arcs and angles. And I'm actually going to zoom in on this one, and maybe we'll just do a little bit of scratch work off to the side. So if I want to find all my arcs and angles, well, I see that this 70-degree guy, that is an out angle, and it's also a 2 tangent because it hits here and it hits here for my 2 tangents. So if I remember 180 minus 70, because that angle and this arc should add up to 180, so this is 110. So this guy right here is 110 degrees for that arc. I'm going to continue with that. If that's 110, my central angle right here is 110, which makes this guy 70 and this one 70 because they got to add to 180, right? It's a straight line. But I also know this is 110. And now I can find a whole bunch of other arcs. This is a arc that's intercepted by that central angle of 110. This 70 degree would then give me this arc right here because it's intercepted by that. And over here, same concept. Okay? So you have a bunch of central angles here, which makes this one not so bad. Now, if I draw a radius to the point of tangent, that's a right angle, and that's a right angle. The same concept would apply over here and over here. I've got almost all of my angles. The only thing I'm looking for is this guy out here. Well, there's a couple ways to do that. Some of you might be saying, ooh, I have a right triangle here, and I know that that needs to add up to 180, so you are correct. That 70 plus 90, subtract that from 180, would leave me with 20 degrees. That looks like 200. Cool. All right. Now, we have an identical situation over here, so this is 20 degrees as well. If you went another route, you could have done big intercepted arc, which is 110, minus smaller intercepted arc, which is 70. 110 minus 70 over 2 is equal to 20. 40 over 2 is 20. So either way, I'd get the 20 degrees for that angle. I've got all my angles and arcs with this circle here. We're good to go on this one. All right, I like it. Let's keep moving. Here we got find all missing lengths. So we're going to be using a lot of our power theorems on this one. So to solve for x, y, and z, it looks like I actually have almost enough information for x. It says that AB is 16. So if I took 16 and I subtracted 6, 2, and 4, I'd be left with 4. Whoa. I'd be left with 4 right here. Okay? Don't know why that shifted. All right. So now I can solve for x by using my power theorem. I know that x times x plus 6, the whole thing, is equal to the outside, which is 4, times the entire thing, which is 4 plus 4 plus 2. Entire thing being the outside portion and what's in the circle. All right. So over here on the left-hand side, I get x squared plus 6x. And then here I have 4 plus 4 is 8, plus 2 is 10, times 4 is equal to 40. So I subtract 40, I've got a quadratic here. If I factor this, I'm going to have x plus 10 and x minus 4, which equals 0. So I'm going to get negative 10. I'm going to get positive 4 for my solutions here. Now, is negative 10 going to work? No, it's not. Only 4 will work for x. Cool. All right, I'm going to switch colors to green as we solve for y. For y, I actually have all my information now thanks to that 4 that I already got over here. So I would just have 1 times y is equal to 2 times 4. So y is equal to 8. Donezo with that one. Now for z, I'll switch to red. For z, it's a tangent secant style style power theorem. So I'm going to have z squared is equal to the outside, which is 6 times the entire thing, meaning this outside portion and what's in the circle. So I'd get, I don't know why that moved. Okay. 6 times, and then it's, let's see here, 6 plus 2 plus 4. All right. Wonderful. So inside here, I've got, let's see, 6 times 2, or sorry, 6 plus 2 is 8, plus 4 is 12, all that times 6 is 72. So I have z squared equals 72. I'm going to square root both sides. I'm going to get z equals, if I break this down to 36 and 2, I'd get 6 root 2. For those of you that are still struggling with simplifying radicals, there are plenty of videos that I've actually made myself, but we definitely got to get that down. It's a big old concept in Algebra 2 honors as well. You've got to be ready to rock on those. But that's everything that we need on that one. Awesome. Number 4. Here we have the ratio of measure of angle A to the arc measure BC is 1 to 3. And anytime I see those ratio problems, I'm going to be like, all right, I got 1x, and then this arc is going to be 3x, right? I use an x along with those for my ratio problems. Find the measure of arc BDC and the measure of angle D. Keep in mind here, this D angle here could be really, it could have been anywhere along the circle right here, and it would work out the same way. That thing could be pivoted anywhere, and my answer would be the same for both the arc and the angle D. It's just because this looks kind of symmetrical, has really nothing to do with that. D could have been anywhere along that arc. All right? Cool. So, what do I know about those, the arc and the angle there? I know that they're going to add up to 180. So it's a two tangent situation, special case, where those two would add up to 180. So I'm going to have x plus, what the heck? I'm not sure why it's jumping around here. It could be because I selected that one thing before, but it's kind of annoying. All right, x plus 3x is equal to 180. So I get 4x equals 180. So I'm going to get x is equal to 45. I like that. So that would be the measure of angle A, which it doesn't really ask me for, and it doesn't ask me for BC either. But hold up, this would be equal to 135 then, wouldn't it? Are we cool with that? That'd be equal to 135. And if I know that that's 135 and I know that D is an on angle, I could just cut that in half and be left with 67 point, that's kind of a terrible 7. Oh my goodness. I'm just going to try deleting this and see if that gets rid of the issue that I'm having here. 67.5. All right. So measure of angle D is 67.5. I like it. All right, we need arc BDC. Well, if I already know that arc BC is 135, shouldn't be too bad to figure out this arc here. A circle is 360 degrees. Subtract out that 135, and what do we get here? Anybody? Anybody? Oh, wait, that's right. I'm just recording this video on my own. Okay, so we get 225. Cool. All right, so that's problem number 4. Let's keep moving. My goodness, this is going to be a lengthy video, I have a feeling. All righty, I'm going to try and speed it up. For number 5 here, I want to find the measure of angle, or sorry, find the measure of angle A in the inscribed quadrilateral. Also, we're going to find a couple arcs. So, in inscribed quadrilateral, this angle and this angle should add up to 180 degrees. So, I'm going to have 2x plus 6x equals 180, 8x equals 180. And if I do 180 divided by 8, I'm going to get a decimal of x equals 22.5. No biggie, that one's not too bad to work with. So I can actually figure out all of my angles at this point. This is going to be 45. This over here is going to be 67.5. And then angle B, 22.5 times 6 is going to be 135. Awesome. And then I could either subtract all that from 360 because it's a quadrilateral, or since my opposite angles are supplementary in a quadrilateral that has been inscribed in a circle, mind you, angle A is going to be 112.5 degrees. Cool. So that gets me all my angles. The measure of angle A is the one that we definitely wanted. But all of them actually come into play when it comes to the measure of the arcs. So AC, I'm going to talk about that one in red here, and hopefully things don't get too crazy crowded. AC is our arc there, and actually the on angle of D is the one that intercepts that arc. So I know that an on angle equals the arc over 2. So if I were to just reverse it, solve for the arc, I'd multiply the on angle. So the measure then of AC is going to equal 2 times 45, which equals 90. Cool. And then lastly, BAD. Well, same kind of concept. I'll go in green on this one. BAD. That one, the intercepted arc and angle associated with it, would be angle C. So if I double 67.5, so BAD is equal to 67.5 times 2 times 2. What's that going to give me? 135. Degrees. Okay. Awesome. Next one. So for problem number 6 here, I'm given that EF and EG are both 8. AB is 5x, and DG is 2x. That is a terrible, terrible bracket. There we go. Is 2x plus 3. Also a terrible 3. Okay. Well, it looks like those two chords, A, B, and DC, are equidistant to the center of the circle, right? Because those, the EF and the EG are perpendicular to the chords, and they're congruent. So distance is measured perpendicularly. So those guys are going to be congruent. Well, how about I set up 5x is equal to, also fun fact, those the EG and EF actually bisect the two chords. If they're perpendicular, they also bisect. So I can double the 2x plus 3, and I'm going to get 5x equals 4x plus 6. So x is going to equal 6. Well, how's that going to help me? If I plug that back in, I'm going to end up getting 2 parentheses 6 plus 3, that equals 15 for just this segment. Now, I'm going to use a different color here, and I've got myself a triangle, a right triangle with 8, 15, 17 is going to be my radius. Oh, the triples, they always come back. So what's my circumference? Well, 2 times pi. That is not what I want. I want a C. 2 times pi times my radius. So I'm going to get 34 pi. Wonderful. Couple more. My goodness. This is a lengthy video. All right, but I guess we got a lot of good problems here, and you can just skip around. So we want to solve for x and y. Well, once again, I have a two tangent situation going on here that I see with this angle, which would mean that DC is 120 degrees. Perhaps that'll help me solve here. I like to just jump into these problems and write down what I know, because sometimes it's helpful to do that, and I can't always directly solve for something. Well, now that I have this, I can do my in angles, and in angle is equal to the arc plus the arc over 2. So x is equal to 50 plus 120. The angle x, or angle DFC, whatever x degrees, that one hits at DC and also over at AB. So these are the two arcs that we're using right there and there. So from that, I would get 170 divided by 2 is going to give me x equals 85. All right. Now for y, I'm going to need to write down some other information. Ooh, that was a solid voice crack. I'm not stopping now. Let's see here. I've got BD equals 10, so the whole thing is 10. I'll save that here. But I do have AC is 11, and I have FC is 8. So I got 8 here, and if the whole thing is 11, this will be 3. And if BD is 10, and I got this section here is FD is Y. How about I do 10 minus Y? I'll keep it in terms of Y. And now my chord power theorem would tell me that, well, y times 10 minus y is equal to 3 times 8. So I'm going to get 10y minus y squared equals 24. I'm going to move everything over to one side. So I'm going to have y squared. I always like to bring that over to the to make my y squared positive, my quadratic term, I like to make it positive. It really helps with factoring. And now I can go ahead and factor this thing. So I'm going to have y minus 6 and y minus 4. So I'll get, I guess I don't really need that, y equals 6 and y equals 4. So I got two possible solutions that will actually work because they're both positive values and they're positive lengths when I plug them back in. Awesome. Two solutions. Cool. Moving on. All right. Two concentric circles have radii 26 and 10. Well, concentric circles, oh man, let's see how this thing snaps into place. We're going to find out here in a sec. All right. Really? You're not going to snap into place? We're going to try that one more time. Really? Okay, whatever. I'm going to leave it. I have a chord of, it says, find the length of a chord that of the larger circle if it's tangent to the smaller. So if that is going to be a terrible line, that's a little better. That chord of the larger circle is resting at this point, so it's tangent to the smaller. Now, I've got a couple radii here that I know. One of them is 26, one's 10. I'm going to draw these in a strategic way. I'm going to make this guy perpendicular, drawn to the point of tangent. That would be a right angle. I'm going to draw this one to create a triangle. So that's 26. And now, if you know your triples well, it would be a 10, 24, 26 triangle. And then the same would apply over here to be 24. That's probably going to bother you guys that I have a weird 2 and another weird 2, you know, two different 2s. Sorry. And then we have 24 plus 24, and that's going to be 48. I like it. Good stuff. That's the last one. Hopefully I didn't make any mistakes. And look at that. We are at 23 minutes or so. America, freedom, rock and roll, Costco.